Hello, I'm audible.
Yes, sir.
What about Jabbar? I'm audible. So what did we study last time? What did we study last time? What did we study last time?
Sir, frequency.
Okay. So we will start with these questions. Okay. So what are the wavelength, frequency, time period, and amplitude of a sound wave? Sorry. Who will answer this question? Who will answer these questions? Who will answer these questions? Riaz, first of all, on the camera. Okay. So we already discussed about what is wavelength, what is frequency, what is time period, what is amplitude of the wave. Clear? We discuss all these terminologies, na? Wavelength, frequency, time period, and amplitude of a sound wave. Suppose if we have a sinusoidal wave, okay, this has the nature of sine theta or cos theta. That's why we say that this is the sinusoidal wave. This is the sinusoidal wave. Clear? So the distance between any 2 points in phase, if I want to say the phase, then that if we will calculate the distance from this is the peak of this wave, and another peak is this same peak, one peak in this part and one peak in this part. If the distance between these 2 points is being called the wavelength, the consecutive distance between the 2 points on the wave is called wavelength, and we say it with lambda. Clear? The consecutive distance between the 2 points on a wave is called wavelength. First of all, on your camera and try to give the response. Give the response. Rumaza, Riaz, Jabbar. On the camera and give the response. Give the response.
Yes, sir.
What? Yes, sir. What is frequency? What is wavelength? What is frequency? I repeated this terminology yesterday, and today I'm asking, and you guys are totally silent. What is frequency? What is frequency? What is units of wavelength? Units of wavelength. Units kya? What is units of wavelength?
Lambda.
What
Lambda.
is lambda? What is it units? It is measured in meter, kilometer, second, Newton. We already discussed yesterday. We already discussed all these terms yesterday.
Sir,
You
meter.
guys are not, you guys really don't study.
Sir, meter.
See,
In nanometer.
we discussed the wavelength in meter. A small m means meter. Who said nanometer? Who said nanometer? If you want to respond, how I will teach you. It's all about the response. I'm waiting over here until you want response, I won't proceed. You answer, then only I will proceed. Who said that nanometer?
Mohammed Riyaz.
Riyaz. So what is nanometer? Why did you say nanometer? What is nano plus meter? What do you mean by nanometer? And how it is different from the meter? Nanometer and how it is different from the meter. Meter. What is difference between these two? Jabbar and Rumeza, what is difference? Riaz got stuck. Riaz on the camera and Jabbar also. Rumeza, you too.
So, difference between nanometer and meter.
What is difference?
Sir, nanometer is the smallest unit.
Okay.
Like,
Yeah, right. If meter is 1, okay, in 1 unit, then nanometer is 10 to the power minus 9 meter. So these are the ratio between these two. Clear? 1 nanometer is equal to 10 to the power minus 9 meter. So basically it is really a smallest quantity, but it is still the unit of wavelength. It may be, but we only say the meter, okay? We don't say the nanometer or kilometer. We say only the meter. SI unit is meter, right? So what is frequency? Now tell me frequency. We discussed frequency yesterday. It means last time. It means I'm not making you understand. Is this you are not understanding my way of teaching? What is the reason?
sir, frequency.
Hmm. What
Number
is
of,
the
like, number of line.
number of oscillation in 1 unit time?
Sir,
Number of oscillation per unit time equal to number of oscillation. Number of oscillation. Number of OSCILLATIO. Number of oscillations per unit time. Per unit time. Clear? Suppose we have a simple pendulum. Okay. And this is a bob. And this is the vertical point. This is at angle theta. So it starts from here, goes here. Suppose it is going over here. So it is doing a to and fro motion. Okay, it starts from here, goes here, it starts from here. So how in 1 second, how many oscillation it is doing? We'll call the frequency.
Sir,
Okay.
non-oscillation means it starts from one point and ends in the same point.
Yeah, it starts from here, 1, it goes here, and again it goes here, 3. Then it goes here, 4, and then it reach over here. So it's starting from a point and reaching again at the same points will be called the one complete oscillation. And how many times it does in 1 second will be called oscillation. Clear? Frequency.
Yes, sir.
So what is time period now? What is time period?
Sir, time taken for
Okay. Time taken?
for an object to do something.
Time taken by an object to make a complete oscillation. So if it starts from point one, it reaches to 2, then goes to 3, then come back to 4, then come back to 5. So how the time taken in this complete motion, it will be called time period. Time period. Time taken in one complete oscillation. Time taken in time taken in one COMPLETE complete oscillation. Clear? Clear or not?
Yes, sir.
Okay. So what is amplitude of a wave? What do you mean by amplitude?
Highest frequency.
No, highest frequency is not highest frequency. I said that the
Highest wave.
distance between the mean
Highest
point
wave.
to this. Okay, this is the amplitude. This is the amplitude of a wave. This is the displacement from the mean point is called amplitude. Clear? So screen is visible or is gone? If you will see in this pendulum, so what will be the time period? Sorry, amplitude. Amplitude will be the maximum displacement from the mean position. This is called the mean position, right? So the maximum displacement from here to here will be called amplitude. Clear? Or not? This is mean position and it goes over here, for example. So that this displacement will be called the amplitude. Means the maximum displacement from the mean position. Amplitude equal to the maximum, maximum LACE, maximum displacement from the mean position. Clear? It's clear to everyone? Respond, then only we will move further. If there are any doubts, kindly ask. So it is being denoted by capital A. How are the wavelength and frequency of a sound wave related to its speed? Anyone remember? How are the wavelength and frequency of a sound related with speed? How all these quantities are related? We discussed all these things yesterday, last time, and now you guys are completely blank. That's really sad. Rumaza, tell me, what are the relation between wavelength, frequency of a sound wave related to its speed? There was one relation. We also solved one numerical based on that. Respond, then only I will move. Otherwise, we will be stuck over here. Unless until the concept is not clear, we won't be moving further. Rumaza, what are the relation between all these three? Turn over your notes. You didn't make the note? This is not the relation.
Sir, is it the formula?
Yeah, this formula we saw yesterday. The speed, how speed is related with frequency and wavelength. You guys really don't revise. I'm sorry. I'm sorry, you guys really. I don't know what to do. So what is the relation between speed, wavelength, and frequency of light? What is relation between speed? First of all, you all open the camera. Open the camera. Open the camera. Open the camera. Open camera. And respond. Tell me what are the relation between wavelength, frequency, and speed? Which, what is the relation between all these three quantities?
So frequency and wavelength are inversely proportional.
Frequency and wavelength are that frequency, if we say nu, is inversely proportional to wavelength. Sorry, wavelength, right? Means we know that V is equal to n lambda. So so you will say that, okay, so it's like V is equal to nu lambda, right? So frequency is inversely proportional to wavelength. That's it. That's correct. But we have a relation between all these three quantities like this. We already mentioned over here. Last time we mentioned speed is related with frequency and wavelength. And we solved one question based on that. We solved this question based on that. But still you don't remember, then it's tough. So open the camera. I'm not knowing what you guys are doing. So Rameza, do you remember this relation? V is equal to n lambda or nu lambda. N is also n is the same frequency. Nu is the frequency, right? We sometimes say n as frequency, or sometime to f as well, sometime to nu as well. These all are simultaneously being used for the frequency. So don't be confused. Calculate the wavelength. Do the third question if you know the relation. Calculate the wavelength of a sound whose frequency is 220 Hertz and speed is 440 meter per second in a given medium. Calculate the wavelength using the same relation. V is equal to nu lambda. Do the third question. Hope you have copied or taken the screenshot of these formulas. I'm going to remove this, okay? I'm removing it. Will you able to do this? Question number 3. Umaza, did you get the answer? Riaz, Jabbar, any of you? So we have to calculate the wavelength. Therefore, lambda will be P over nu, and V is given as 440 meter per second. Meter per second. And
110.
frequency is 2
Sir, 110.
hertz. Right, this is hertz is inverse of second. So you may write this second and then second will get cancelled.
Sir,
10
answer is 220.
2. Only 2 meter, right?
Yes, sir.
Yes.
Where you guys were roaming around? Calculate the question number 4. Calculate the question number 4. Riaz and Rumaza, open the camera and respond. These questions are based on previous day question concept. Fourth solution of 4. A person is sitting 450. This is source, and sound is being emitted all side. Okay. And a person is sitting over here. So the source, the frequency is 500 hertz, right? So it is being asked that what is the time period? What is the time interval or time period? So we already given a relation between frequency and time. So use that relation. That's the same simple relation. Frequency is 1 over t. We have to use this relation. It will be that t is equal to 1 over frequency. And you know the frequency is given already, so calculate that number.
So I got the time interval as 2.
Time interval as 2. So it will be nothing but 1 over 500 hertz. So how you got the time interval of 2?
So 1 by 500 equals 0.02. So
0.002. So how you got to 0.002 seconds? So sound takes this much time to repeat itself. Sound is taking this much time to repeat itself. So see how quick it is. If you will write it, it is like 2 into 10 to the power, what, -3 or plus +3? Tell me. If we will convert this, it is like 2 divided by 1230. 1230. So it will come like that. Second, this much second. So sound is repeating itself in the time interval of 2 into 10 to the power of -3 seconds. So it is so quick, right? So all these questions are clear?
Yes, sir.
Any confusion, any doubt? Hope so.
No, sir.
Again, I will ask tomorrow, then you all will be blank. So there is one term called intensity of sound. Intensity of sound. So if you are in club, okay, if you are in club and suppose you are in prayer room, prayer room. So these two places where you will find the sound is very loud. In club that all the sound systems are on. Sound systems are operating in club. In prayer room, there is complete peace. So where do you will find the loudness or intensity? What is the scenario of club or a prayer room? Prayer room. In the club, there are noise and noise everywhere, right? But in the prayer room, we feel that it is very quiet and peaceful. So if there is sound, more sound in a specific area, then we will be calling it the sound intensity. Clear? The amount of sound passing each second through a unit area is called sound intensity. And sometimes we call it loudness as well. Okay, but loudness is defined in some different way. Both are not, we use interchangeably, but they are not the same. Loudness is the measure of the response of the ear to the sound. Clear? Any doubt?
No, sir, no doubt.
So speed of sound, do you think speed of sound is different in different medium? The speed of sound is different in different medium. Suppose this is air, okay, and there is a iron piece. So do you think that sound will be same in both medium? Or air or hot air? Suppose you have hot air, cold air, cold air. So do you think that the speed of sound will be same in all these three type of air? Hot, cold, or it will be different? It will be same or it will be different in all these three medium. Tell me, Jabbar, do you think that sound will be same in all these three medium? One is just simple air, one is hot air, means summer days, one is the cold air like winter days.
Sir, same.
No, it won't remain same. In hot days and in colder days. So sound depends on the temperature. If it is hotter day, hot airs, then it will move faster. So it depends on the materials. So it differ from medium to medium. So have you seen the thunderstorm?
Yes.
Thunderstorm. Okay. So which reach you faster? Suppose you are standing over here and thunderstorm is over here. Okay. So sound travels and lights as well. Which one of these two reaches you first? Sound or light?
Light, sir.
Okay, so it means that light travels faster than sound. Clear? Light travel faster than sound. So light has a speed 3 into 10 to the power 8 meter per second. And it has 344 meter per second at 20-degree temperature. So there is a relative table over here. So we will see how it changes with mediums. So see, in air, the speed of sound is 346 meter per second. Whereas the speed of sound is 3 into 10 to the 8 meter per second. So speed of sound is much larger than the speed of air, speed of sound in air. That's why we see the light first, then sound. So see how it is changing. In aluminum, it is 6,420. For nickel, it is 6,040. For steel, it is 5,960. And so on. In the glass is only 3,980 meter per second. Among these, aluminum is the best conductor of sound. Similarly, seawater, the distilled water, ethanol, and methanol. So seawater is the best conductor of sounds in the water, in the water group. Similarly, in the gases, hydrogen has a maximum capacity to conduct the sound, and it is decreases slowly. Clear? So it depends on the medium as well. Another topic is reflection of sound. So when you hit a ball, this is a ball, right? This is a ball. If you will hit on the wall, this is ball. So it will reflect back. Okay, so in the same way, the light is also reflects when it hit a surface. So suppose this is a clock and the night very peace over here, and this is a wall. So if you will make an arrangement like this, you will find that if such arrangement is being made, that the incident angle, this theta, and this theta are equal, then you will hear the maximum sound intensity. Clear? So sounds reflects when you will speak in front of a tall wall, okay, and you put in a speaker, then you will feel that sound is getting reflected from that wall and reaching you again. Have you ever noticed such phenomena?
Yes.
Okay. So this is called the reflection of sound. What is the echo? Echo of sound.
Rebound of like sound.
Echo is rebounding, or so echo is the if sound is again and again oscillating or vibrating around you, there is some system that used to make the echo sound. That's give the flash of sound after a regular interval of time. Clear? So this is the echo. So there is some more terminology, tone or so tones. What do you mean by the tone? Tone and pitch, huh? The another word is pitch. P-I-T-C-H, pitch. What do you know? What do you mean by tone and pitch?
Pitch means shrill voice.
Sorry,
Pitch means shrill voice.
still voice and tones.
I don't remember, sir.
Okay, pitch and tones. Let me see. I'm putting the definition. Where is pitch and okay, high pitch and sometimes we say na high pitch and low pitch, high and low, high tone and low tone, high tone, low tone. So these are actually the loudness of the sound. Okay. So if this graph shows this is the loudness of sound. Okay. So if this plot shows the loudness of sound. So this is the amplitude. So amplitude is large. It means the loudness of tones is sound is large. So it depends on the amplitude of sounds. So at the same time, suppose you are playing the flute, F-L-U-T-E, flute, okay, and same time a drum is being played. So you can distinguish the sound of all these operators, okay? That's because of their characteristics. CHRCHAREC characteristic. Because flute and drum, sorry, it is drum. So flute and drum will make the different sounds, and they will be having different characteristics, right? So based on that, we can differentiate between the sounds. Clear? So do we have any numericals based on today's class? Let me see. Then we will move.
Sir, does tone and pitch mean the same thing?
Sorry,
And tone and pitch, are they the same thing or different?
they are slightly different.
What is the difference?
Both are the characteristic of sound, okay, and high tone. If someone has very smoothing sound, so you will say that, okay, you have the good pitch, okay, and someone has not the smoothing sound, then you may say that, no, his or her pitch is not good, okay. And the same that tones means that if a loudspeaker, heavy loudspeaker is being played, okay, so its tones will be too much high. And if you play a small, weak loudspeaker or speaker, then you won't get the high tones. So these are the differences. Clear?
Yes, sir.
Okay. So now we have a small example question. So let's first put it on the screen and then we'll come back. Reverberation is like, are you aware of this term? Reverberation is like you might have seen that cinema hall or theater. They have a different type of structure. Their roof is curved. You will find that their roof is curved. Okay, if this is a screen and you are sitting over here, so its roof is being designed in such a way that the sound will come after each reflections. Okay, so such type of procedure is called reverberations. Clear? You might have seen the different infrastructure in the theater. The high roof, high and curved roof. So now I put one question and hope you will answer this.
Sir, what is the question?
Question is still incomplete. Let me complete it.
Sir, is there a formula for echo?
Not that much. This is a simple question. Let me first fix it. A person clapped his hand near a cliff and hear the echo after 2 seconds. What is the distance of the cliff from the person if the speed of sound is V is taken as 346 meter per second?
Sir, you have to use distance equal to speed by time.
Yes, use that formula only.
Sir, 173. No, the unit meters.
73. Oh.
Sir, distance equal to speed by time, right?
Let me see. S is equal to V into T. Okay, that
Sir,
is distance.
it's not. Sir, it's not V by T.
Speed into time. This is the right reason. Okay. You are not giving the right relation. So suppose a person is over here and the cliff is over here, right? So it takes
Yes,
time
it's
from this
90.
to this and then come back. The whole time is 2 seconds. Clear?
Yes, sir.
And speed is 346 meter per second. So just put 346 into 2. So this will be, the sound is going from one person to the cliff and coming back. So the distance will be
962.
690 meter. But the question is that what is the distance of the cliff from the person? but it's include the both way, this and this way, right? First sound is going from person to the cliff and then returning back. So you have to make the half.
346.
So it will be like this is the distance. This distance means one round, distance of a complete round. But for one way distance will be 692 divided by 2. So 3, 4, 6 meter round. Clear?
Yes, sir.
So now repeat all the concept what is being taught over here. Clear?
Yes, sir.
And try to respond. If you won't respond, it is really tough to communicate, right? It's the classroom. So we have to make it both way. Clear?
Yes, sir.
Any doubt?
No, sir.
Okay, then see you next week, hopefully. This chapter is almost complete. Okay, this has only some terminologies little bit. And yes, range of hearing. Okay, so one is ultrasonic and that's only one topic, range of sound. So the range is only between 20 hertz to 20,000 hertz. So we listen in the range 20 to 20,000 hertz. Beyond the 20,000, it's called ultrasonic. And before that, we give it some another term. So that term is, we say, ultrasonic and infrasonic. Yes, less than 20 hertz is called infrasonic, and more than 20 hertz is called ultrasonic. So clear?
Yes, sir.
So we here in the range. So last topic, why to keep that 20 hertz to 20,000 hertz, right? So
Yes, sir.
the range where we can hear the sound. This is called ultrasonic. Ultrasonic. This is infrasonic. Less than 20,000 is called infrasonic.
Sir,
Infrasonic.
the next topic is not there, right?
Sorry?
Sir, the next topic
Next topic? What?
in this chapter, like,
Next topic is range of hearing, right?
no, sir, the one after.
One after is use of multiple reflection of sound, right?
No,
Okay.
sir, after that, on the last two something.
The reverberation, right?
Sir, wait.
So it is the special arrangement. I told you, in cinema halls or in theater, you will go that you will find that roof is made in the different shape. Okay. So the sounds come back to you. So that's called the infrasonic. Sorry, reverberations.
No, sir, sonar and
Okay, sonar is
transducer of human ear.
sonar is not in the online version of NCRT. Okay,
Transducer of human ear. Also, sir.
sonar is aesthetic use of there is use of multiple reflection of sound. So loudspeaker and horns, then stethoscope. Okay, so sonar is not in the present syllabus. I'm using the online version. Okay, clear?
Yes, sir.
So if any small topic is being left, You kindly read yourself because it's really the statements only. Okay. So if you find any difficulty, we will be reaching you again. So I'm leaving you with some questions and try to solve all these questions. Exercise. Okay, all exercises. Half of the exercises we are going to give you for practice. Clear? Any doubt? Any
No,
doubt?
sir.
Okay
No,
then.
sir.
Then now try to come with practice. Okay.